Hello, everyone. Let's get started. Thank you all for coming to Performance Tuning for Developers. We'll just start by introducing ourselves. I'm Erin Miller. I'm the Manager of Performance Engineering at MarkLogic. I've been with MarkLogic about 8 years and have some special expertise in systems resource management and monitoring.
I'm James Clippinger. I'm MarkLogic's Vice President for Strategic Accounts. A number of people have asked me what exactly that means, and if anyone has some ideas, please let me know. But really, I lead our global performance team. I work with our customers everywhere on performance issues, sizing systems, capacity planning, stuff like that. And I've been with MarkLogic almost 10 years at this point, and I've worked with a number of the people in the room here and a lot of people at the conference.
Great. So we'll start off by talking a little bit about the agenda, just to let you know what to expect here. So first, I'm going to talk about MarkLogic and how we use systems resources, and with a focus on systems utilization. And the reason for that is just often we don't think about that as developers. It's kind of like, yeah, we'll worry about that when I have to. And so having some information up front so that you can think about that proactively is helpful. So once I get through that part, then I'm going to turn things over to Mr. Clippinger, who's going to talk about some of the kind of a deep dive into some of the common code issues, as well as generally some things to look out for, and then we'll take some questions. One other kind of announcement before we get started, we'll be repeating this session again tomorrow at 1 o'clock. So if your friends missed it and they're really disappointed and jealous, you can let them know that they can come see us tomorrow. And I'm also going to be doing an expert one-on-one general session tomorrow morning at 8 a.m. So if anyone has any follow-up questions that you don't get answered today, feel free to come see me tomorrow. So let's start with this, and this is what I was talking about a minute ago. Why should we as developers really care about all this system stuff? My code is really good, it's optimized, it runs really fast. I did everything that Clip told me to do, and why do I care about I/O and CPU and all that kind of stuff? And it really comes down to when you're in production, when you get to a point where your application's deployed, but all of a sudden there's like a massive slowdown, you don't know what's going on. That's kind of my traffic jam here. And it's like, oops, everything worked great except we needed more I/O. So my role is to just kind of help you think a little bit more about systems utilization and what that, why that matters with your application. With MarkLogic, one of the things that's really helpful in terms of having a good, a system that's running fast and running well, is to think about it as this balanced system. And so, from a systems capacity perspective, that's these 5 components. And so we'll talk about all of this as we go here. This is a diagram. This is actually from a white paper that we published recently that's on the developer site. You can search for resource consumption, you'll find it there, and we have a link at the end as well. But this is just kind of an architectural diagram to give you a sense of what is in the server, and we'll talk about these various components and the system resources that they use, as well as what you need to think about when you're writing your code. So I'm going to focus today on basically two pieces. There's a lot more operationally that we could cover, but right now I'm just going to talk about ingest, and then I'm going to talk about queries and system utilization from the perspective of those two processes, because really as developers, that's what we really care about, getting content in there and then running queries to execute searches. So we'll start with ingest. Just to review what happens when you insert content into MarkLogic, you have, a document. The application sends a document to a MarkLogic app server. The document is loaded into an in-memory stand. The transaction is written to a journal so that in case of a failure, it can be replayed. And then periodically, that in-memory structure, we call it an in-memory stand, that gets flushed to disk. So you'll have all of these documents in memory, and then they periodically get flushed to disk. And then as you do updates, as you do deletes, as you're changing your content, Their merging will go on in the background. We'll talk about that too. And basically merges are there to reclaim disk space and to optimize the indexes. So we'll talk a bit about what happens, what that means. So what is this? I think merges are something that often we'll get a phone call into support, and it's like, can we turn off this merging thing? It's messing up my application. How do we make this stop? And I think it's important to understand what it is and what's happening in the background. You're just writing a XDMP document insert, right? So it's like you just know you're getting the data in there, but what's happening in the background with the system? So when merges occur, you have multiple stands, and stands are the data structures on disk. You have multiple stands that get combined into a single stand, which means you get disk space reclaimed. So that's a good thing. It's sort of a self-tuning system. You want disk space to get reclaimed. You also get index optimizations at that point. So we have index structures for the in-memory stand, and then we have index structures once that stand is flushed to disk. So the process of the merge, where it's cleaning up deleted fragments, and it's also doing index optimization. So a big question is, when does this happen? Can I control this? Can I say when merges will happen? You certainly can. You can have merges happen when you ask the server to merge. There's a manual merge that you can do, so that's an option. But merges will happen automatically in the background, and it's based upon these merge settings, the max merge size, and the merge min ratio. And you can read more about that in the documentation, and we'll talk a bit about how to tweak that. So that's kind of the background overview on what's happening when you're just writing your line of code to insert a document into MarkLogic. What does it mean from a resource perspective? So there's, when we talk about these 5 things these 5 components of systems that you need to think about, there's storage. So there's, the total. You need to think about storage, because the merge process, you're basically appending documents into the database, then reclaiming space. So for merges, you need to think about having the total indexed storage size plus 64 gigs per forest. Now, if you're doing HA, meaning if you have a disaster recovery site, let's say you're doing database replication. So you're replicating to a second site. Then you're in a little bit of a different world, because what happens if you've broken the database replication connection? All of a sudden you've got all these transactions that are piling up that need to be replicated. So all of a sudden your storage your storage requirements could grow potentially as those documents are queued up. So think about, this isn't for exactly every situation, but it's sort of a good rule of thumb in terms of what you need for storage. For IOPS and the behavior that you can expect to see, it will be spiky. As you see these in-memory stand flush to disk, you'll see all of a sudden a big spike of disk writes. So that's expected. That's normal behavior. And I think, sometimes as a developer, you might have a storage person come to you and say, something is wrong with your database. Look at the I/O. It's like spiking all over the place. What's wrong with it? Are you doing something weird in your code? This is totally expected and normal behavior. So that's an important thing to keep in mind. With merges run as background I/O. So they're happening, particularly when you're doing ingests and updates, but they are, what you'll see is, it'll be reported by the CPU as the nice percentage. So you'll see, that the background I/O process is running, and you'll see that nice percentage, and that generally represents merges. That'll also, in terms of what else is used when you're doing ingest, the CPU obviously, is impacted by merges, but also the index creation and updates of indexes. You'll see memory increase as the content is loaded. Basically, the tree, term list, triples, reverse caches are actually, the triples cache is dynamic. So you'll see sort of a memory growth increase there. You'll also see potentially a memory spike at the end of your merge. So there's a setting called preload map data. So when that's set, all the memory map data is loaded at the end of a merge. So you may see a period of time where all of a sudden there's a big I/O read at the end of a merge, and all of a sudden the memory increases. And that's just going to be your preload map data setting. And finally, in terms of network, if you're using network attached storage, think about the impact there that you've got. That you're going to be basically doing all this network communication every time you're also doing disk read and writes. If you are using network attached storage and you're using MLCP, which is our content pump way to get data into MarkLogic, you might want to consider using fast load if possible, just because that does in-forest placement. So and particularly if you have a larger cluster, it's a helpful way to reduce the network traffic around your cluster, but there's only certain conditions under which you can use it. So you want to only do it for new content. You only want to do it if the forest topology won't change. So you may or may not be able to take advantage of that. So just some general tips. When you're writing your ingest code, one thing to think about, often we're transforming data. So you're loading content, but you're not just loading it as is. You might have a whole transformation process that's going on. Keep in mind that transformation process will often be using queries, right? Because you might need to look something else up in the database. There's different read, even potentially different write operations you might be doing. So when you're doing those transformations, remember that there's a cost associated with them, and just try to reduce the complexity as much as possible. Think about the queries that you're running while you're also doing ingest. And Clip will be talking more about this as well. So in addition to like your basic, merge, the sort of basics around ingest, you're also potentially running lots of queries. And so the other thing that's important to think about there is how that will scale. So don't just run your ingest code in dev and say it works great. Look at what that's going to look like as you scale, and we'll talk about that in a moment in terms of queries. The other thing to be careful about on ingest is transactions, and in particular, one of the common bottlenecks we see is kind of a locking problem where there might be a document that you need to look something up from as you're doing your inserts. And what you may or may not realize is that you're actually locking that document for write because it's within the same context, the same transactional context. So all of a sudden, you have this big bottleneck because everyone's waiting on your lookup document. So there's things you can do to alleviate that. You can use a separate transaction. Just important to keep in mind how documents are locked, and what are you reading and what do you intend to be locking at the time that you're doing your ingest. The other thing that I would say is to make sure that you understand with storage the implications of your ingest and that you're going to need extra storage for merges. And try to explain this, across the board. Like if you can explain this to your sysadmins that here's what I need for storage, and having that, our basic general guidelines and parameters around storage is really helpful. Because you don't want to run out of merge space and then have your database be down in production and have everyone be yelling at you. Why didn't you tell us? What about the storage? So it's an important detail. And I would also say planning for scale is a huge, huge thing. And again, Clip will talk about this as well. And just running your code in dev isn't enough. And it really comes down to, okay, it works great when I have 1 million documents, but what happens when I have 100 million? What's going to happen to me? What's going to happen to these queries that I'm running on ingest? So keep that in mind, as well as monitoring as you're going. So I'm going to just briefly talk about an example of how to identify an ingest bottleneck. I'll start this by saying there's only a problem if there's a problem. So one of the things that happens is sometimes people say, I see really high I/O weight. Is that a problem? It's like, well, it's only a problem if you're not meeting your SLAs, and I think it comes down to What is your requirement? You might have a very, very heavily utilized system, but if you're meeting your SLAs, you know you have a heavily utilized system. It's okay. It doesn't necessarily mean that something is broken. And I think that, drilling back into what are your system requirements, what are your customer requirements, what are your SLAs, that should drive whether or not there's a problem. So in this case, I have a situation where, we're running ingest, and then periodically we're noticing that everything slows down. There's these periods where things slow down, and then it seems to perform better again. So how do you figure this out? So looking at the monitoring history is often a good first stop. There's also plenty of system tools available that you can use as well. And my colleagues Silvano and Mark did a presentation yesterday about that. You can find that once the slides are available if you missed it. But let's take a look at what's going on with our system. So quickly in this case, looking at CPU, you can see that I/O wait is nearly 41%. So the CPU cycles are spending a long time waiting for I/O. And so obviously when you have an I/O bottleneck, can't we just add more I/O? And in some cases you can quite easily. You could, however, with if it's local disk, you might need to add more nodes, you might need to add more forests, although that wouldn't necessarily help in this situation. You would have, you would add additional forests on additional nodes, and you might need more, more IOPS from your network attached storage or your SAN. So that's kind of your easiest first step. And Clip will talk about some other ways to potentially optimize your code to reduce I/O impact. Another thing you can do is you can actually throttle background I/O. This will only help you with merges and database backups and restores. But if merges are in fact impacting your query performance, if things are bad enough that you've got these merges running and it's actually slowing down your queries because you're using enough background I/O that it's impacting your system, you might want to consider this setting. And this background I/O limit. 100 is a good starting point. Open a ticket with our support team and work with them on moving this number around to figure out what the optimum situation is. So that's certainly a good option. So getting back to our overall server architecture, now we're going to talk a little bit about what happens with queries. And in particular, so with queries, what we were talking about primarily with ingest was sort of all happening down here with your forest and your what we call a D node or a data node. We also have this concept of an evaluator node, which is a separate process where you're running your app server and doing your query evaluation. In most cases, everybody's running an E and D node as a shared process on MarkLogic. So most configurations have both an app server to evaluate queries and also data available and attached. So let's talk a little bit about queries and how we resolve queries. So much like ingest, here's just the process that we go through here. So we execute a query on an app server or an E node. If you're running a search or an XPath expression, our first step is to resolve the query against the indexes, and that happens on the D node. Second step is to filter the result on the E node. This is a process of loading the fragment from disk, verifying the match. Step 2 is optional. It's used to eliminate false positives. And let's think about what it means for 100,000 docs, for 100 million docs, for a result set that's 1,000 results. You're loading 1,000 documents from disk, so it can have a big impact. One of the things that we see often with this is just that you end up with a number of long-running queries. So this is something that happens if you're unintentionally running filtered queries, then you may often see a number of long-running queries. In this case, we see these I/O spikes. We're spending all this time reading things from disk. Our queue size, our wait time, our utilization are all kind of getting higher there. And you can also look at the monitoring dashboard to see what the longest running queries are. So in some cases, filtered searches are not only preferable, but they're required. So I'm not saying never use filtered searches, but if you can tolerate false positives, if you expect to have a false positive and your application requirements can tolerate that, then definitely go unfiltered. And okay, how can we reduce false positives? Try to get your index settings to match your queries as much as possible. You want to be able to resolve everything from the indexes rather than having to actually open a document and figure it out from looking at the document. Caches. So caches are important. We're going to talk about the caches. Most of the caches that we care about are on the D node. There's one on the E node, but we'll talk about that briefly. So on the D node, you've got your list cache that's got your term lists. Compressed tree cache is our binary representation of the document after they've been read off disk. The expanded tree cache is like the XML or JSON that's coming back to the calling client. There's a triples and triples values cache, and those are both holding triples and triples data. And we've also got memory map files, range indexes, and lexicons. Cache sizes are optimized at install. And they're based upon the available memory on the server. If you add memory to your host, you need to increase your cache sizes. They won't automatically resize. So it's something that we do at install time. But if you've added memory to the boxes, you need to reconfigure them. And if you're running separate D and E nodes, you need two different groups with different settings for these caches. So E nodes should have more expanded tree cache because they're the ones returning the expanded representation to the client. They don't need as much compressed and list, and it sort of goes the other way for the D nodes. They need more compressed and list, but not as much expanded. I say here, don't forget about reindexing, because on reindexing, you do need some expanded tree cache for D nodes. So if you have separated a separated config, don't just set the expanded tree cache to nothing for your D nodes. Cache partitions, we've got each cache defaults to 1, 2, 4, actually more than that, depending upon how much memory you have. And having more partitions is good. It increases concurrency, but it means that each cache is smaller. So you could potentially run into cache full exceptions more frequently. So it's something to keep in mind and balance depending on what your requirements are. So the caches, you don't have to worry about them as a developer, and that's kind of great. The caches, the documents and termlets are added to caches on the first request, and then the cache partitions are responsible for, aging out stale items, and so you don't really have to worry about it. If you specifically want to clear the caches, you can restart the server. There's also an API call that you can use to clear the caches if you don't want to restart. So another way to say this is that when you start the server, your caches are empty. So if you're in production, you want to warm up your caches, particularly the list cache. So it makes sense to run some warm-up queries when you're in prod. So some overall takeaways from this. Don't use filtered searches unless you really have to. Tune your indexes instead. Warm your caches, as I just said. Looking at your cache partitions can be helpful if you're trying to increase concurrency and get better overall throughput, but look out because you don't want to make them so small that you start running into cache full exceptions. Make sure that you're monitoring I/O in particular at scale. I/O tends to be the thing that ends up, when you run into production problems, that tends to be the thing. CPU can also be an issue, and all of our resources can be an issue, right? Memory, CPU, storage. But make sure you keep an eye. I think we forget, particularly at scale, what the difference is. And Clip will talk more about the I/O impact at scale. And basically just do whatever he says. I should have started that. I should have started that way. Just do what clip says, and everything will be fine. So efficient coding is really important. He's gonna dive into some common code issues and take it from there. But I just wanted to give you kind of an overview of what's happening behind the scenes. So I'll turn things over to Clip.
Right. Thank you very much.
You're welcome.
Aaron makes me sound like a horrible tyrant, which I am.
It's true.
But yeah, I get by nonetheless. So I'm here to talk about some common code issues we see working with customers. And so these are all examples from the real world. These are things, they're all xQuery examples. All the same lessons apply to JavaScript. But the other thing you'll note is that this is all custom code that people have written, not usages of our own APIs. So because Aaron's team performance tests the REST API and the Search API and all the other APIs we provide, they really insulate you from a lot of the most common code issues. So the very best way to avoid code issues is just not to write code in the first place. But we'd have really boring lives if that's what we did. So let's talk about some common code issues out there. But first, a reminder about scale. And particularly when it comes to the speed of disk access versus memory access versus network access. Disks are really slow compared to everything else. And because of that, when you're tuning your queries, you should focus first and foremost on disk access. We'll talk a little bit about CPU, memory, and network as well, but just keep in mind, if you can save a little bit of disk, that'll pay for a whole lot of savings if you spend time trying to optimize the other things. And this brings us to the movie review section of the presentation. I'm here to tell you about a little movie called Powers of 10. It's a short film by Charles and Ray Eames that you can see on YouTube. They made it in the 60s. And it is about relative size in the universe and the effect of adding another zero. It zooms out to the universe size and then it zooms into the atomic size. And that gives you some sense of when I say disks are really big in terms of disk performance. So this is the Chicago metropolitan area from a 10K view of it. And so really big picture size of things. And so priority items for disk are things like avoiding unnecessary fragment reads. If you read fragments and you don't do anything with them, that's not good. It's about creating efficient cache behavior and using the cache as well, and thinking a little bit about how the caches will be used. And then it's also using term lists when in-memory options are available is not the way you want to go. If you have an in-memory index, you might as well use it. It's going to make your code faster and more efficient. So let's talk about one of my least favorite performance issues we see, implicit sorting. We all know sorting is bad in computer science terms, right? It's an n log n operation. It takes time. And one of the things I like about xQuery is there's only really one way to do sorts. There's only an order by in your flower expressions. But there's another way you can have a sort creep into your code. So let's say I do a CTS search. It doesn't matter what the CTS search is, but it returns documents. It returns the top 10 documents in relevance ranked order. And I'm pretty happy with this. I'm feeling pretty good. But someone calls me and says, could you change your library to return the root element rather than the document node? Because some reason, I don't really care why. And so I say, okay, I'll go do this. And I change my code. And so now I return the element, just the root element, just a little change. And I'm still returning just the 10. And this works fine in my development environment, but then I move it to production. Performance crashes. It just doesn't work. And eventually, when it does finally return, it returns an exception that the expanded tree cache is full. And this is perplexing. I don't know why this is. And the reason that's happening is because CTS search returns documents in relevance ranked order, but as soon as you use XPath, XPath has document order, which is an entirely different order. So the search results are all returned, they're all brought into cache, and then if there's enough room in cache, they're all sorted into document order. Then the top 10 in document order are returned by this expression. So this is a really sneaky way that a search can get into your code, and it's searching fragments. So it's pulling all the fragments back off of disk, it's keeping them all in memory at the same time, and it's not good for performance. But how do we find that? So how did I find this with the customer I was working with? And this is where XDMP query meters is very useful, because it'll show you, if you run it as part of your query, what the expanded tree cache hits and misses are. So here I was expecting it to have a total of 10 uses of the expanded tree cache, right? Because I'm only returning 10 fragments. Instead, it's 1,010. That's way higher than I was expecting. And that gives me a sign that the query is doing more than I think it is, and that it's not providing the value that it should. So here's an example of the bad form. Here's an example of the good form. Just a small difference in the expression. You get the first 10, and then you apply XPath to it. You're still sorting those 10 into document order, but sorting 10 fragments that you're returning anyway, they're already in memory, that's not so bad. Maybe not ideal, and you could avoid it with a for expression if you wanted to, but you don't have to. But this is the sneakiest form of this problem, is if you have a list of search results, you then do a bunch of other stuff, you go about your merry way, and then you do XPath on that list of search results. This is going to do the same exact kind of sort. So this is one to really watch out for. And really, once you get a list of results back, the best practice is always to have a predicate on it to limit the amount of, well, I was going to say damage. I should probably be a little more positive than that. It can do. And then we move into avoiding term list queries. So we have this query, and I wrote this, and I'm very proud of it. Going through, doing a word query on an unlikely phrase. So that's going to be a short term list. There's going to be relatively few documents that have this phrase. And then I'm doing a second query for a collection. And this takes a lot longer than I expect, because it turns out that loading the term list for the large collection takes some time. Maybe I'm running out of disk bandwidth, whatever reason. But I can work around, and I can see that's happening using XDMP plan. So this is another very useful tool for tuning your queries. Plan shows you how MarkLogic plans to run your query. And here it's saying, I'm doing a collection large query, and this is a term query. I can see right here in the plan that it says term query. It's using a term list. I know that's how it's doing the search. So to avoid this, I happen to have a collection lexicon set up. But I do need some way of accessing it, and there doesn't seem to be any sort of CTS collection lexicon query out there. That's where you can use the XDMP collection special Q name to say, use the collection lexicon for this query. I also need to say, and this is why it's sort of an ugly slide to present, use the code point collation, because the collection lexicon is in the code point collation. But use the lexicon. That uses an index that's already in memory that's super fast, and you avoid loading the large term list. And now when we do our XDMP plan, you can see that what was a term query before is now a range query. Range queries have to run in memory. It's just how they work. And it gives you the information about it. So we've talked about disk. Let's move on to network. Let's think about how we can avoid unnecessary round trips and how we can reduce payload sizes. And this brings us to a different sort of query out there. So this might be my first, X query that I write, and I'm super excited because I'm new to MarkLogic, and MarkLogic's awesome. And I say, this is great. I can get all my primary keys and then just return the first 10 primary keys for this query. And I've got primary keys, and I'm a very happy developer. But then I actually want to return the documents, not the primary keys. So I say, all right, well, I've got my list of primary keys, and then I cycle through my list, and I return the document for each primary key. And so this is how a lot of people start out with XQuery. But keep in mind, so it takes one round trip to get the list of URIs and return it to the enode. It then takes 2 round trips for each fn doc call, because it's doing one for index resolution and then another to actually fetch the fragment. So if your query here actually returns 10 documents, you're doing 21 round trips across the network to pull them back if you use this form. It's relatively easy to fix, though, because you can just say fn doc the whole list of URIs that you want to use, and then it's going to pass that sequence over to the D node. It's going to return all the documents in 2 round trips, sorry. So this ends up being a total of 3 round trips. 1 to generate the list of URIs, one to run the query and do the index resolution, and then one to fetch all the fragments back that match. But you can do even better by actually writing a query to do it. So if you write a CTS search, this does exactly 2 round trips, one for index resolution, one to pull back the fragments. And one thing we're using here, let me see if yeah, it does work. No, it doesn't really show up that well, so you'll have to put up with my pointing. We're using CTS index order here. So this is a way of telling CTS search to return the documents in URI order rather than relevance ranked order, which is the default. So we're still getting the exact same set of documents from this expression. So if you care about it being alphabetically the first 10 URIs, you can get that using this syntax. Otherwise, you can leave out that option and it works just fine too. Then we move on to memory. And memory, I talk with customers a lot about memory, but it's also one of the things that in your code you have the least control over, because a lot of it comes down to the caches which are already pre-configured for you. So if you're looking at memory, keep in mind that lexicon calls are very, very fast because they're going against in-memory indexes, but that doesn't mean they have no cost whatsoever. They still require some CPU time. They still require time to get the data out of memory. So if you're doing really huge lexicon calls, it may improve performance to find ways to reduce the size of those lexicon calls. In particular, I sometimes see customers who are so used to lexicons being fast that they get way more values that they need and then do some logic to filter them out. If you can instead push the query logic into the lexicon call itself to limit the number of documents you're bringing back, that'll be way faster. And then the other thing is to consider your memory use holistically. So another very common situation is I have all this RAM, MarkLogic is only using half of it. How can I change something to make MarkLogic faster and use more of that memory? And that's something, first it goes back to Aaron's point of, do you need to? Is there an SLA that's not being met, or are you just trying to optimize because we're engineers and we optimize? Because it's very common when I ask that question to be like, well, no, it just seems like a waste to have the memory sitting there. But the other thing to keep in mind is the memory is not just sitting there. Unused memory in the operating system under Linux and Windows as well, but we mostly look at Linux, is used as buffer caching for whatever the system's doing. And MarkLogic is designed to use available memory for buffer caching very efficiently. So even though that memory is sitting there and seems not to be doing anything, it's actually helping your performance and giving you value. So it's something to keep in mind is that it may not be worth it to crank up the size of your MarkLogic caches. You may be better off leaving it for OS caches. And with that, we've got some additional resources here. These slides will go out as part of the post-conference materials. A very key point here, inside MarkLogic server has just been updated for MarkLogic 8. It's all new material. It's pretty awesome. The Understanding System Resources white paper that Aaron mentioned before, there's a direct link to it. The documentation has the performance guide, and there's also clustering information, and the cluster guide provides information on that. And with that, we'll open it up for questions. We are going to have to repeat each question, so please try to keep them short and not too sentimental. Yeah.
Concerning the operating system, what are the main differences between Linux and Windows?
So the question, in terms of performance, you're saying? Yeah. So the question is, what are the main difference between Windows and Linux for performance? Do you want
Sure, yeah, I can take that one. So I don't have an exact number, but there's we definitely see better performance on Linux, and part of that is just that we are closer to the kernel, we know what's going on, we're able to optimize our system calls in a way that we can't on Windows, and that it's somewhat of a black box. So there's definitely a performance benefit to being on Linux.
And the thing I would add based on field experience is we have had bugs uncovered in Windows in the operating system itself by MarkLogic customers related to performance that Microsoft has either been slow or unresponsive to fix. So that's one reason we tend to recommend Linux for performance-sensitive customers. Yeah.
Where in the code we insert XDMP query meter or XDMP plan?
Good question. So the question is, where in the code do you insert XDMP query meters or XDMP plan? And for most developers, it's while you're writing the query, you would use Query Console. So XDMP plan actually wraps around the query. XDMP query meters, you call it the point in the query where you want the metrics. And so you usually just sort of type them in there and go from there. Are you familiar with other ways of doing it?
No, just that, with query meters, it'll give you statistics on the last query that you executed, so you can just add it to your code and it'll kind of spit that out.
Yeah.
Query meters you would need to return. I know that plan is in the logs, right?
No, plan is also.
Oh, also need to return
it's
the
returned.
results. So
it's returned as part of the query results, which is another reason why Query Console tends to be where you use it.
So for example, an add-on to the same point. So we write most of the custom queries, right? So if you write a custom query, and if you add this HTML plan, how do I visualize it? Because some of the servers do not have access to the logs. I mean, we don't have access to the logs.
So. Yeah, sorry, I got to repeat the whole thing. So the question is how, let me make sure I got this right, how do you get the information from XDMP plan or query meters when you don't necessarily have access to the server the code's running on? Is that correct?
We don't have access to the logs.
To the logs.
If it's
Right, okay. And usually you're using these at development time. Usually you're not going to use these in production. This is where the full-scale production testing comes in, where you want to have an environment where you can try everything and then get the output back. If you're in, because sometimes we are in weird environments where you can't get logging information back, you could write some checks on top of XDMP plan or XDMP query mirrors to make sure things look about right, but it would be difficult. These are really debugging tools.
Yeah, and yes, and you can also use Query Console to do that. So you can return the results from plan in Query Console. That's probably the easiest.
The first one you said of the word query, if you run the HTML plan, it provides you the detail. The second one was the network calls. Does that also HTML plan will provide the network calls also?
So in that case, query meters would provide the network calls. Yeah, plan is given this query, how do you plan to run it? Query meters is what's actually happened in the query up to this point. So the metrics kind of split between those two, and
This is the common way we write the code when we find the word query.
and it's very. I usually have to run one, and I'm like, oh, that's right, it's the other one that I need. So it's yeah. Yeah.
Aaron, you mentioned there's two parts to the ingest process. One when partially filled stands get combined, and the second part when they get flushed to disk.
Yeah.
Which is the merge?
Right, so the question was about the ingest process and what exactly is going on there. And so when you insert, you're inserting into the in-memory stand. So it's first loaded to memory. That in-memory stand is periodically flushed to disk. In addition, in the background, the merge process will run. So it's a separate process, but it's triggered by ingest and changes in your...
Is the merging of stands together?
Yeah, so is the merging of stands together, and that's exactly right. And if you've had deletes, it's the cleaning up of fragments that have been marked for deletion. Get rid of those, reclaim space, put stands together, and optimize indexes.
That was my question about the space.
Yep.
So if the merging is for in-memory stands, well, how is disk space?
Well,
Merging doesn't happen in memory. Merging is going to happen for the stands on disk. So the in-memory stand gets flushed to disk, right? Each forest has a single in-memory stand.
And it's tiny. It's very, very small.
Yes, it's very small. It's going to be happening frequently. That as you're ingesting, you're writing to memory, and then this gets flushed to disk, and it creates more and more stands. And then periodically, the merges consolidate these on-disk structures. So the merges are always dealing with what's on disk.
For X-query that may have a number of statements in it, is there an easy way to determine which of the statements in that overall procedure is most time-consuming?
So the question is, if in multiple statements in XQuery, is there a way to tell which statement is the slow one? And by that, do you mean statements in the formal sense, because you can have multi-statement transactions, or separate expressions?
So there's separate expressions, I think,
Okay.
you showed where
Got
it's
it.
the for loop.
Yeah.
in the same bit of code.
And that's, I mean, I think profiling is the best tool for that, which in Query Console, there's a profile button. If you push that, that will give you some idea usually of what part of your code is running slow. And that's a lot of the examples we looked at here are ones where it just takes incredibly long time and it never returns, or it times out before it returns. That's the more common way to say, okay, I've got a bunch of loops. I'm not sure which loop is taking all the time, is profiling. Well, we got one way back there.
I was wondering about the performance differences, if there's any between using XQuery versus JavaScript. And then also, I was wondering about the marginal performance hit for non-native languages.
So,
Sure.
so the question is JavaScript versus XQuery for performance and the hit for using foreign language packs, right?
Foreign language packs was the second question?
But non-native.
Okay. Okay, yeah, so JavaScript.
Non-native, like, program. Oh, okay.
Yeah,
Got
I didn't think it was
yeah,
foreign language.
Yeah,
You know, it's like those other languages.
Yeah, I don't know.
So JavaScript, XQuery are very close. We did a lot of performance work and performance tuning on the JavaScript engine before we released it. You're not going to see a big difference, and if you do see a big performance difference, you should log a support ticket and work with us to figure out what's going on. The JavaScript piece is coming to us from, we're using the V8 engine, so it's very highly optimized to start off with, and then our implementation on top of it is also optimized. So you should see really good equivalent performance. In terms of with other languages, are you talking about like a UDF or what? I'm not quite sure.
Or Python or.
I mean, yeah, any non-native languages that that's used.
Yeah, I mean, so, with non-native languages, there's different ways of handling that. I think one of the really common things that we see is just to use the REST API. And that's pretty much what you always want to do because that is highly optimized for performance. And it just provides, HTTP endpoints. You can use whatever language you want to get a view into the data, to execute queries, whatever you need to do.
Yeah. Question over here.
Can you shed some light on load balancing?
So the question is, shed some light on load balancing. Load balancing, it's generally best to configure a load balancer for sticky sessions because the caches that exist on the enode level, it's better if a user is pointing at the same enode all the time. It avoids recaching the same materials. How you achieve that, it varies from place to place. Because I've worked with customers who use cookies to do that. I've worked with customers who just point an entire shard of their application layer at a single enode and have the load balancer just handle failover. Enodes, if you have separate D and E nodes, a single enode can usually handle a lot of traffic. So you may get by with relatively few enodes and be able to do something where you just point all your traffic at one enode and have a couple for failover. Yeah.
And not use WebDAV and load balancing.
You can WebDAV and load balancing.
Yeah.
So was that a statement or a question? Okay, so the statement / question was you cannot use WebDAV through load balancing. And I believe that's correct. You also can't use the legacy XDBC protocol through load balancer, which is tricky because it sure looks a lot like HTTP if you're a load balancer and it's coming through. But that's something very few customers are doing right now. Yeah, Jane. Okay, I assume we're going to have a statement.
We do support load balancer for existing, but it's not
If you use the HTTP form, right? Right.
Yes.
But that's the legacy. The old protocol doesn't work through it. Yeah.
Any recommendation for optimizing the Sparkle queries and triple stuff?
That's a whole nother presentation.
Yeah.
The question is optimizing Sparkle queries, and
Yeah.
it's
Talk to us afterwards. I might be able to help with that. There's some trace events. I can't, top of head, I'm having a little trouble but we can talk and I can give you some information about what to do there. Yeah, there's similar tools to like XDMP plan and query meters with Sparkle. There's some trace events so you can see what's going on. So I can help with that.
All right. Sorry, we hit the end of our time.
Yeah, feel
thank
free
you all
to,
very much.
to come up and thank you.
And